Hi, welcome back to the Calculus 2 lecture series. And we are in the unit number 1. We just started unit number 1 on the applications of integration. And this is our lecture number 1. And this is the second part of our lecture number 1. We are talking about the areas between curves. Okay, so let's go back to our lecture notes we stopped last time. Okay, so for the part 1 of this lecture's first lecture, we talk about how to find the area between the curves, and we talk about the two basic one, like this is the one, if you want to find this area, the yellow area between this function, the pink function and the green function, or the other simple one is like if you want to find the area between the function f of x and the gx. So we basically talk about finding the area with respect to the variable x, and we talk about the area with respect to variable y. So in the second part of this lecture, we're going to kind of still try to find the areas between the curves. But now the area is not that nice anymore. So that means probably, sometime we need to divide the area into several sub areas and then try to find it. So for example, like what we did here. Okay, so let's take a look here. Okay, so so for example, right now we have curves here. Okay, so like what we did part 1, we just have f of curve, g of curves, and now in here we say, okay, how about in here I have a curve here. This is my, let's say here, this is y equal to the f of x here, and then I have another curve here, something like that, and I will say this is the y equal to the gx. And now I want to find the, excuse me, the area between these two curves, right? So basically I want to find this yellow area between these two curves. And now, because here, these two curves intersect, right? So we have one extra work. That means I need to find the intersections here. Okay, so these intersections here, right? So this is A and this is B here, right? So the first steps here, we need to set what? Because this is the intersection. So we need to set the f of x equal to g of x. And then we want to solving for x here. Correct? So then I can find the curve, I find the area because I know the area will be the integrations, and then you use the curve on the top minus the curve on the bottoms, right? So for this type of the integration, I would say, hey, I'm integrating from A to B here, right? Then what do the curve I use? I use the top curve. So it's the f of x and then minus what? Minus g of x. And then I'm taking the, the dx, right? So respect to the x. Of course, you can do respect to y. So I just want to show you the, what is the part 2 is a little bit different than what part 1 we try to cover. Okay, so now let's take a look. So sometime, your curve is like this. Let's see here. Okay, so like, for example, one of my curves go like this, right? So I would say this is, let's use the same notation. So this is y equal to the gx here. And then let's see here. So if I have another curve, I go like this, my purple curve. And then I will say this is y equal to what? F of x. So the first thing is you want to find the area between those two curves. So these areas here, that means will be this area, right? This yellow area is between these two curves. And this light pink area is between these two curves here, right? So now for this ones here, what you need to do, you still need to set these two curves equals, right? So you still need to set the f of x equal to what? G of x. And then you want to what? You want to solve for x. So correct? So you will solve for x. So you will find the A and the B and the C here. So the area for this one, so it's first one, if you take a look, the yellow areas, right? So yellow area is from the where to where? A to B. So which one is on the top? It's the green one. So what is the green one? Is gx. So you need to say it's gx minus f of x and the dx, right? Then you plus the area of this light little pink area. So the pink area, what is the area between? It will be between the B and the C's, right? So the B and the C's here. So what is the, which one is on the top? Right now it's f of x is on the top, right? So you do the f of x minus what? Minus gx dx here. So now this will be the overall area between these two curves. So the little actual works we need to do is try to find where is the intersections. And then we might need to divide it into several sub-intervals, sub-areas, right? So because it depends on how the curve behaves here. All right. Okay, so now let's take a look at our problems here. So it said write an expression of definite integral of the area region bounded by the y equal to x plus 1 square and the y equal to x plus 3. Okay, so y equal to x plus 1 square, that's the parabolas, right? So the center will be at -1. And when x equal to 1, this will be 1. X equal to the -2, this will be 1. And when the x equal to 1, this will be what? This will be 4. All right. All right, so here this will be 4. So okay, so I can hope that I can do a good job and get this parabola up beautifully. Very difficult, not bad, not bad. Okay, so this is my y. So this parabola is y equal to x plus 1 square. And now I need to find another curve is y equal to x equal to 3, x plus 3. So x equal to 0, y equal to 3 is here. X equal to -2, y equal to what? Y equal to 1 is here. And let's see here, when x equal to 1, y equal to 4. Okay, so this line, this green line is y equal to the x plus 3. So now let's see. Okay, so now I'm going to find the area between these two curves. All right, so let's try to, let me try to use a different color. So we try to find this yellow area, right? So this yellow area will be the area we try to find. Okay, so just like we did before, so the one extra thing here is we need to find the intersection points, right? So you will set the x plus 1 square equal to what? X plus 3. Right, so then here you will have x squared plus 2x plus 1 equal to x plus 3. So you will have x squared plus x minus 2 equal to 0. And now you factor it, I think, right? X minus 1 equal to 0. So what is the value of x? X equal to -2 and x equal to 1. So is our graph did a pretty good job. We got that. Okay, so now I'm going to integrate, so the green line is on the top, right? So since the green line is on the top, and then we can go like this way. right? So go down, so you have the green line to minus the purple lines here. So what is our areas here? So our area will be what? So from where to where? From -2 to 1, right? So here, this is from the -2 to 1. That's where is this point, correct? Okay, -2 to 1. So we need to use the green one to minus the pink one. So it's x plus 3 minus x plus 1 square and the dx. Okay, so now you can FOIL it, and this will be a pretty straightforward. Okay, so this will be a pretty straightforward integrations, right? So you can just FOIL this one. So this is x plus 3 minus x squared minus 2x minus 1 dx, and then you can integrate that. I'm not going to spend the time here to integrate. I assume you know how to do that easily. So the answer for here, this is 9/2 here. All right, so this is the first ones here. Let's take a look at the second ones here. The second ones here is that, hey, find the area by the shaded region. So for these areas here, so I know I have this yellow area and I have this little pink areas, right? So as you can see, for the little yellow areas here, so for these ones here, I use the purple, right? So this will be x cubed, and then the pink, then the straight line. The straight line I can use here, y equal to the x squares, right? Okay, so now, you know, let's take a look at the areas here. So the overall area, okay, so the first one will be the yellow ones, right? So the yellow one, okay, so the yellow one is the pink, right? So this is the where, so this is the pink one, so it's x cubed minus 3x squared plus 3x, because so it's a cube one is on the top, so you minus the what? Minus the green ones, right? Then the dx. Now, what is the area? What is the x value from where to where? From 0 to 1. All right, so let me color code that for you. So maybe, so we are looking for here, this is the, right? So this is the 0 to 1. And then in here, the minus x. So this is the, you know, the green curve, and this is the purple curve, right? So that's how to get you the yellow one. Okay, so now you need to plus the area for this little pink one. So the little pink one is vary from 1 to 2, correct? But the pink one, which one is on the top? Is this line is on the top, so it's x minus this pink curves here, right? So this is x cubed minus 3x squared plus 3x dx, correct? So let me color coding that, so be easy. So this is a 2 to 1 because we are looking for this pink curves here, and because of that, the curves here is below. So that's why it's here. So that's why you need to use this linear line to do that. So for these ones here, you can do just like we did before. It will be pretty simple. So it just simplify that. So this is x cubed minus 3 square x plus 2x dx and plus 1/2. And then minus x cubed plus 3x squared minus 2x dx, right? Then you can use the integration, so it will turns out to be a 1/4 plus 1/4 equal to the 1/2. Yeah, right. So this one is pretty straightforward. So we just need to be careful, you know, when we do the regions here. Okay, so now let's take a look at this one. This one is a kind of a interesting ones here, right? So I want to find the area of shaded, you know, for these shaded regions. So for this ones here, okay. So if let's take a look. So if I want to do the integration respect to the x's here, right? So you can use this curve minus 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 this curve. It works good all the way to 0. But if you take a look at the zeros here, from here, if you go like this way, then it will be this curve to its curve itself, right? So you don't have a curve to minus here. So I know for these little areas here, I cannot do respect to x. I might need to do respect to y here, correct? All right, so let me erase this here. All right, so now that means that I might need to divide the curve here. Okay, so this region is the yellow one. Okay, now this region is what? This is the region, the little pink one is the regions here. Okay, so a while ago, we already said, so the overall area, these pink areas here. Okay, so let's take a look at these pink areas here. The pink area, so is from 0 to pi, right? So 0 to pi, like I mentioned before a while ago, for the pink area, if you take a look at the integration to the x, you can always from this curve to this curve, right? Okay, so the pink area will be what? So it's from the respect to x. Well, but in here, my function x equal to y minus 1 squared. So I need to have a f of x minus gx. So I need to do something for here, right? So I need to solve for y. So now I can see here, this is y minus 1 squared is equal to what? X plus 1, right? Then you take the square root. So this is y minus 1 is equal to the x plus 1. Now, when you take the square roots, you typically have a plus minus. Am I right? All right, but in here, because this pink one is, I'm only look for the positive one, the y greater than 0, correct? Okay, so then I don't need to worry about the plus minus. This will be plus, right? So finally, I move the 1 over. Now I will say this y equal to the x plus 1 plus 1, right? Square root of x plus 1 plus 1 here. So this is for the pink areas, right? So I can use the top curve, right? So what is the top curve? The top curve will be the square roots of x plus 1 plus 1, then minus what? Minus sine x dx, right? So let me color coding that for you, right? So here, this is will be my, in here, so this will be my little pink areas, right? And then I'm having here, right? So this will be, you know, this sine curve, right? So this is a sine curve will mean by green one, and this pink curve is here, right? So this is my pink curves here. So that's why here, this is pink one, and the minus 1 here, right? So one of the things is very important is this one's here, right? You need to do a little bit of manipulation to change that. Okay, so this is my pink area. Then I need to class. Okay, so this is respect to x. Like we said, this yellow area respect to x is not going to work. So what do we need to do here? We say, hey, we need to do this way. We need to integrate this way. Is respect to what? Respect to y here, right? Okay, so now respect to y. So y is from 0 to 2, right? So this is 0 to 2. Then what is this one? That is starting here, right? So it's from the, you know, so what is this value here? This will be the zeros, right? 0 minus what? Minus this pink curves, right? So this pink curve is what? Is y minus 1 square minus 1. Now, what do you do here? You do dy's here, right? So now let me color coding that so it probably will be clear. is better, right? So this will be so this area is the one you try to, the integrator here. All right, so this is my what? This is my purple curve. So where is this zeros here? Let me use a different color. This zeros will be, okay. Okay, so let me erase the, so here, okay. Okay, so this zero is this zero is the y-axis here. All right, so this is the zero, it's y-axis. So it's 0 minus y minus 1. Then be careful here, right? So what you're integrating about is dy here. Okay, so be very careful about these problems here, because you need to be very careful to see where is the areas here. Okay, so now after that, then the integration part will just be pretty straightforward. And okay, so in here I already calculated that. So my answers here is not too beautiful, but if you do the calculation, and so this is will be 3 to the 2 pi plus 1 to the 3/2 plus pi minus the 4/3. Okay, so basically you just need to plug into by, like for example, this one you need to use the substitution rule, and this one you need to FOIL it, and then just do the integration. And I have confidence you should know how to do it, right? So this was not too bad. That's what you learn at the end of the calculus 1, how to do the integration. Okay, so now the next one is here. I'm going to find the area. Okay, so this is the one I'm going to find the area between these two curves here. Okay, so now in here, between the sine x and the cosine x here. So like we said, the first things here, in order to do that, what do we need to do? So we need to set the sine x and equal to the cosine x. As we know, where the sine x equal to the cosine x, because here's the pi's, right? So we know they are equal to, because both the sine x and the cosine x equal to the square root of 2/2 at 45 degrees, right? So I know the x is going to be what? X is going to be equal to the pi what? Pi over 4 here, right? So then also in here, they intersect here, right? So x going to equal to what? 5 pi what? 5 pi over 4, right? The 5 pi over 4, so both of sine and cosine x is going to be equal to the negatives, right? So here, this is my A, this is my A, this is my B, right? So it will be pi over 4, 5 pi over 4. So after you solve it, then the integration will be pretty easy. So the area will just be what? You integrate from where to where? Pi over 4 to 5 pi over 4. And which one is on the top here? So this one, right? So this is a sine function. So it's a sine x minus cosine x and the dx. So I got the answer is 2 of square root of the 2. So just use the unit circle to find the value and the basic the trig function integration. All right, so now let's take a look at these ones here. It says to write an expression involving definite integrals for the area bounded by the region y equal to 2x and the y equal to a minus x squared. All right, so like we talked about here, we always need to do a graph here. Okay, so y equal to a minus x squared. So this looks like is the what? This looks like the parabolas, right? So so when x equal to 0, y equal to 8. So I have this, okay. And when x equal to 4, x equal to 2, let's see here. x equal to 2, what is y? 2, so y equal to 4. So I have a point here, x equal to -2, so y going to be same here. Let's take a look, other ones here, when x equal to 4, x squared is 16, so it's -8. 4 will give you a -8. Okay, so -4 give you -8. It's pretty good. And now let's see here, I can get a beautiful parabola, not all. Oh, that's not good. This one is difficult. Okay, so let me see here. All right, so gee whiz, it's not easy to draw the lines here. Sometimes I get lucky. I can get a one draw. Okay. All right, not bad. Okay, not bad, not bad. Okay, so now let's take a look at my y equal to the 2x. So when x equal to 0, y equal to 0, going to pass in here. X equal to 2, y equal to what? Oh, y equal to 4 is here. X equal to -2, y equal to -4. Right? X equal to 2, -2, y equal to -4. So it's here. All right, so this is a line. So here, okay. Oh, it looks like I have several lines. All right, so here. Okay. Okay, so like we say here, okay, so right now, this my graph is not too accurate, so I cannot just look at the intersection point, so I need to physically solve it. So I will say y equal to the a minus x squared will be equal to the 2x. So let's solve it. So this will be x squared plus 2x minus a equal to 0 factor, right? So I will have x equal to 2 and x equal to what? -4 here, right? So this is my intersection point, and I'm finding the area. So this area is pretty straightforward, and it's just the pink one minus the green one. So, okay, so the area will be what? From where to where? -4 to what? -4 to 2. So the pink one will be a minus the x squared, then minus the green one 2x dx. Right? So if I color coding that, then 2x is here, that's my green line, and this is my purple one here. All right, so this integration is pretty straightforward. You can just go ahead and do it, and this will be the 36 here for you to check it. So when you finish, you just integrate that, and the answer should be 36 here. Okay, so let's take a look at the last ones here. So the last ones here, they say write an expression involving the area bounded by this. All right, so let's always graph it. Y equal to x here. So it's the diagonal line. Right, so let me see, I can get this one. Okay, not too bad. So I use the color coding here. So now let's take a look at my y equal to -x will be this one, this diagonal, right? Okay, so will be this diagonal. So let me see here. Okay, so this diagonal, so this one is this diagonal. Okay, so now let's take a look at the other ones here. The other one is y equal to 2x minus 3. So x equal to 0, y equal to -3. So something here. All right, so x equal to 1, y equal to -1, x equal to 1, y equal to -1, x equal to 3, y equal to 3. See here. right? X equal to 3, y equal to 3. Okay, so this one's here. So the hope that I can get this good. This is difficult to draw, especially this angle. All right, let's try again. Okay, so here. All right, not bad, not bad. All right, so I am looking for the area bounded by these 3 lines here. So basically, I'm looking for the area bounded by these 3 lines. Okay, so we say, okay, what we can do? We say, hey, we can integrate with respect to x, right? So the only problem is in here. Okay, so you need to divide this one. So in here, so from here, okay. Okay, so on the right-hand side, so of this region, you can do the integration like this, right? So from using the purple line to the blue line. But when you switch to the left-hand side of the integration, then what happens here? Now, this one's here, you will be a purple line to what? Purple line to the green ones here, right? So for these ones here, you need to separate the area. So the first thing here, let's try to see what is this intersection point. This intersection is the blue one. So let me try to color code that. So this is the blue ones, right? So all right. So this intersection is the blue one and the purple one. So you will say x equal to the 2x minus 3. So what is the x here? X equal to 3. So when the x equal to 3, the y equal to 3. So this intersection point is 3, 3. That's what we need. And then we also need this intersection point. This intersection point, right? So this one's here. This intersection point is the blue and the green. The blue is like a 2x minus 3 equal to the negative x, the blue and the greens, right? So what is the x here? X equal to 1, correct? Okay, so when the x equal to 1, so what is the y value? The y is equal to x equal to 1, y equal to the negative 1. So this point is 1 and the negative 1. And then this is easy. This is 0, zeros, right? Okay, so now let's go ahead. So the area, right? So area for this part to the left will be from where to where? The 0 to what? 0 to 1. Then which function is the left here? So is this purple minus green, right? So the purple is x minus green minus x and dx, correct? Okay, then plus to the right-hand side of this line. So from where to where? What is the x value? X is from 1 to 3. And now is which graph? Which line is, which curve is on the top? This purple one. So it's x minus, what is the bottom one? Is this blue one, right? So it's a minus 2x minus 3. All right? And then dx. So now after you do that, this will be pretty simple, right? So this will be just 0 to 1, x minus x is 2x dx. Then plus this is 1, 3, and this will be the 3 minus x dx, right? You just simplify that. Then this integration, I'm very confident everyone to know how to do that. So the areas here is the 3 here, all right? So this one is a little bit complicated, but it's a very good problem. So you need to be very careful. So when you try to do the integrations, right? So you say, okay, from here for the right-hand side of this divided point, I can always use the purple one to minus the blue one. But after you pass here, you cannot use the purple one to minus the blue one. So it should be the purple one minus the green one. So that's how do you divide this area into 2 parts, right? So let me make sure this is part 1. This is the second part, right? So this is the, okay, so this will be the 0, 1. So this is the what? This is the part 1, and this is what? This is the part 2 here, right? Okay. All right, that's it. That's it for the first lecture, how to find the areas between the curves here. So we start out with a very simple one and we get a little bit more complicated. So you just need to graph it. So graph the curves is very, very important. And then find the intersections, right? And then take a look, you know, the area we try to find, do I have to divide it into a sub area? Or I can just directly use f of x minus gx, or, you know, or I might need to integrate with respect to y instead of respect to x. All right, that's it. And it's nice to, you know, work with you guys for this, how to find the area between the curves. That's it. All right, talk to you later. Okay, bye. Have a good day. Okay, bye-bye.